Okay, at least in Ghana, it is now 10 a.m., 7 minutes past the time, yeah? So good morning. I hope you're all doing great. Somewhere in Namibia, I think it'll be good afternoon now. Okay, let me see your response in the chat. How are you doing today? And how is your cloud journey going so far? Just type something in the chat to confirm you can hear me. Awesome, awesome. Am I loud and clear? Am I very, very audible? Okay, great. Okay, then let's get started. Let's get started. So let me see my friends. Where are you speaking from? I want to see whether some of my international friends were able to join today. So just let me know the country you're joining us from. Do I have my Namibian friends here? And then my Rwandan friends were they able to join the call today? Just let me know in the chat. And obviously my people from Ghana. Okay, okay. Gizo says from Accra, Ghana. Benjamin Petit. Okay, great, great. UAE, amazing. Namibia, wonderful. Okay. Yeah, I was in South Africa, I think some 2 months ago. I wanted to trip to Namibia. That's like just an hour from South Africa or so. But unfortunately, my itinerary didn't permit me. But I will definitely be visiting Namibia one of the upcoming months. Yeah. Awesome, awesome. Nice to have all of you today. Great. So let's get started. Let's get started. And once again, this is Cloud with Shad. There's a whole team behind this whole program. And let's take some time to really appreciate the guys. They've really been helpful to me, the support team. And even some people even volunteered to support, right? I saw that in the chat and I really appreciate all the effort. We are all putting it together to help ourselves. We are the very ones who make Africa great, right? So sometimes we don't have to have the mindset that always if something good will come, it must come from the West. No, Africans can help ourselves. And that's one of the reasons why we put together the Cloud with Shad program, a free program right from here from Africa, West Africa, the whole Africa being exported to the whole world. So this time round, we just limited it to Africa, but soon we open up our gates to accept students from all over the world, all over the globe, right? At least it sends a signal that there's something good in Africa. Africans are not always people begging for help and funds, right? We can also export help, knowledge, and skills outside for free, right? And that's exactly one of the things that is inspiring Cloud the Shad. And you guys are making it a dream come true for all of us, not just for me. Okay, thank you so much. Now let's get started. So we have just started with week number 2. We just completed week number 1. Maybe you are just joining us. Today is your first time, right? It is not too late. All these materials will not be taken down even after the 4 or 5 weeks. All these materials will still be available, right? And you can have access to it throughout the entire year, right? But Elon Musk says something interesting. He says that if you give a man somewhere like, let me just paraphrase it. If you give a man 3 months to finish a task, he used 3 months to finish it. If you give the man 3 years to finish the task, he will still use 3 years to finish the same task, right? And I think it's even possible to give someone 3 weeks to finish the same task, and he use the 3 weeks to finish the same task. So why the boot camp? Why don't I just say that, okay, this boot camp is just open for the whole year. You can do whatever time you feel like doing it. We are limiting ourselves and trying to work within 4 weeks, right? so that we are forced to finish this on time and move on to other things. We can't spend the whole time learning cloud foundations, right? So please just, I ask you from the day one that up with me, lock in with me, and let's do this together. So that by the end of the 4 weeks, you are done and you've dusted all of these stuff and you are ready to move ahead to other things. You don't have to spend 3 years on this. No. So we finished with week one. It's not too late if you are just starting. Just come to this page. Today we'll change the domain name. Probably today, tomorrow, we'll change the domain name to just cloudwithshadowgroup.com, right? Because this domain is not easy to keep in mind, right? So we'll move this to cloudwithshad.com. Then you can easily remember and always access all the materials whenever you want to learn for free. Okay, so if you are getting started, there's a whole support Q&A group. Make sure you join that group. If you get stuck, ask questions in that group and I'll be there. The teammates are there. Other people who are volunteering to support us are also there to help answer questions. And this week, we are just starting with networking and architectures. So as usual, we'll take our short slides. If there's more time, look at the VPC lab that we have to perform. So 2 labs every week. I usually try to just do one or even just give highlights. The lab work is not for me to do for you, right? It's for you to do for me. But sometimes people get stuck. My team comes in to help you finish them up. And at the end of this week, okay, all those who are able to do all these labs, that is lab 1, lab 2, lab 3, lab 4, will issue certificates, right? Something to just give you a pat on the back before we even begin week number 3. So at least rest assured, if you've done all 4 labs, 1, 2, 3, 4, you get a certificate for that, right? And if you're able to finish the labs for week 3 also, meaning you've done 6 labs in total, we'll give you certificate of completion, right? You finish the course with Cloud Shadow. And those who are able to now do the final project, they will be given a super, shall I say, super intern certificate or super bootcamp participant, right? So that's those who go the extra mile to finish the last capstone project with us, and we add their own flavor to it. So there's a basic certificate for those who finished just the first 2 weeks with us. Those who are able to complete the 3rd week and all this lab content, we give you completion certificates. Then for the super guys, those who want to get the super certificate, you finish the capstone project and we give you that also. Awesome. Sounds good. Just type good in the chat for me if it sounds good. So yeah, sweet. Great, great, great. Okay, so without wasting time, let's get started. I know the road is difficult, right? It can be a difficult road, so we have to do things to make to keep you guys going. So today we begin with a story. We begin with a story. So every week there are stories to help solidify or make your understanding on some of these technical stuff go easy for you. So week 1 was Makola Market, a very popular market in Ghana. Then we also had the Postman, right? Now week 1 seeks to explain IAM and its related concepts. Then that's identity and access management. Week 2 also seeks, the Postman also for week 1 also tries to explain regions, availability zones, edge locations, right? So we can look at these 2 stories. But today I'm just taking this one to just help us understand VPC subnets, knuckles, security groups through Kojo's farmland. Okay, let's get started. So AWS networking can be quite intimidating if you're a beginner, but let's make it simple today using Kojo's farm. So there's a farmland in a place called Nkrumah Valley. Nkrumah Valley is a place right here in Ghana, right? You can visit Ghana and look for Nkrumah Valley, or just ping me when you get here and I'll take you there. So Kojo has a great farmland. Now this is Kojo you see here inside his farmland. Now in his farmland, okay, there's a boundary. Someone will say border, right? No one comes in, no one goes out without Kojo's permission. So in AWS terms, this is what we call a virtual private cloud. So as you're using AWS, okay, when you sign up for AWS, we have a group of services that can live within this boundary, and there's a protected boundary, right? Hackers cannot get access to the things inside your VPC. That's if you create it very well in a very secured manner. So the purpose is to give you privacy. That's why we call it the virtual private cloud. So you have absolute control over what can access the things in your virtual private cloud and what cannot access, right? What goes in and what goes out. Full control. Good. And that's exactly what Kojo also has. A farmland with a boundary. He has paid for it and he owns it, right? He inherited it from his family. Okay, good. Now, every single soil in it, everything belongs to him. So we've seen the VPC. Good. Now, when you get inside his farmland, okay, there's some further demarcations in the farmland. So he has an area he calls the public farm and another area he calls the private farm, right? Now, why has he made this difference? So he wants the private farm to offer more security, probably for some of the foodstuffs that are being grown on the farmland. And for the public farm, this is where he grows crops and sells to everyone, every other person in the community or in his country, right? So private farm is probably just for himself and his family, right? This is where they live, they grow stuff here and they feed on this stuff. This is like a subsistence kind of farming. But for this land, public farm, he grows stuff to sell to the market. And people may come here to come and buy stuff from there. People who are allowed to enter his VPC. Okay, this is that idea. So we now know what a subnet is. So subnet is just a demarcation within the VPC. If the VPC is the whole farmland, or you can even say the whole real estate land. Within that land, we have demarcations. A private area reserved with more security, and the public area which has less security. The security is not as tight as what we have in the private area. And we'll call these demarcations subnets. So within a VPC, we have subnets. One can be public and one can be private. Private has more security. Fewer people are made to access what is there. Very restricted area. But with the public, we may allow people from the outside, when they come to visit our farm, we don't even take them to the private farm. We just walk them straight to the public farm, show them around. It can be students who have asked for permission for an excursion. They want to come and learn about our crops. We don't take them to private. We take them to public farm. Every other person who wants to visit our farmland is taken here. But for this private farm, the family, Kojo's family and loved ones, they are the only ones who go here. Okay, awesome. That's clear. Let's continue. Now, we have security on the farm, right? And the security, we are going to talk about two levels of security. So the first level of security we are speaking about is for the demarcations, these areas we call the sub-networks, right? So the public farm has a security around it. So the boundary you see around it is its security. Then the private farm also has its security around it. That's the boundary around it, right? And what we say about this security around the subnet, so we are taking one of them, is that this security is stateless. Stateless means that it doesn't really have memory. It doesn't remember. Another popular way I explain this, okay, is that let's liken this one to the security guard or the security personnel at the airport. Now, when you get to the airport, okay, before you enter the country, right, or leave the country, your passport has to be checked. Now, just tell me in the chat right now, do you think those guys at the airport remember who came in and who left the country? Tell me, do you think they have any idea? Or they keep track of those stuff on their head? Yes or no? Obviously not, right? They're not going to memorize your names and your face. And you'll get to the airport, they'll be like, oh, it's been a long time I saw you. It has never happened to me before. Those guys don't keep pictures of your face in their head, right? As soon as you get there, all that they care is to check your passport, your details, and ask you some few questions and do inspection. So those guys are the stateless guys. And we have security guards like that at the subnet level. So the subnet is a big farm. The public farmland and private farmland, they are very big areas, right? Let's say hundreds or thousands of acres of land. This farm is no small farm. Now, people entering and leaving the farm, we don't expect the security guards at the main entrance of the public farm to keep memory of all the people who are coming into the farm. They don't do that. They just check maybe your ID, and they ask you of whether you have an invite to enter the farmland. That's what they care about. Okay, good. And when you are leaving, also, when you get to the gate, they will also check your car again. You see whether you are not taking any goods away from the farm, right? So those are our, what we call the stateless security, okay? And in AWS, we call them NACLs, Network Access Control List, NACLs. Awesome. So on the very big area, that's a subnet, the security guards encounter many people every day, let's say hundreds or even thousands of people entering and leaving the farm. They don't keep track of anyone's face. They just check your details, inspect your car when you're coming to the farmland. When you're leaving, they do the same thing. They will not say, hey, oh, remember you came in. As you are going out, you can just go out freely. No, they will check you, just like the guys at the airport. Awesome. We understand knuckles. Let's go to the next thing. Now, when you enter the farmland, okay, I hope you've all seen these kind of houses or homes before, made up of mud house, right? Right now, I learned that this is now going to become the next generation technology. Something our forefathers used so many years now. They've now realized that these are the best buildings for Africa, because inside these buildings, oh my God, it's even more than AC, right? I visited my village and I slept in one. In fact, I overslept in one because it feels so cool. See, we really have to appreciate what we have here in Africa. Our technology, what our forefathers use, is the best, trust me. And they have a pot, they put water inside. Oh my God, the taste is so good. I took a sip and I was like, sweet. This is water I've never tasted before. Okay, moving away from that. So when you get into the subnet, right, you've already bypassed that security, those security who behave like the guys at the airport. They are stateless. Right now, each person, okay, or on the farmhouse, we have these homes. Now, with these homes, we have security guards also at these homes, right, at their gate or their door. Now, these security guards also behave like the ones we have at our homes, right? The one at my gate, the one at your gate, right? And how do they behave? When you are coming to the house, they will definitely check your credentials, right, or your ID, and find out from their list. Maybe at the beginning of the day, I told my guard or my security personnel, see, I'm expecting this and this and this person. If they come, allow them to enter. Any other person, I don't want to see any other person the whole day. So at that level, they have a book with them of list of visitors they are expecting on that day. If you are not on that list, they'll just give you an excuse that Shad is not around or Susie is not around. So that list, will come to it later on. We'll call it the route tables, or let's say the security group rules, right? We'll come there later. But just know that these guys are the gate. Now, imagine this. Let me ask you another question. With these guys at our gate as security guards, when someone enters the house, if they allow you to enter the house, they check your ID and you enter the house, and you've come to visit Shad, and you are going out of the house, what do you think happen? Do you think they'll want to check your ID again and look at your face? Let me know. Would they want to check your ID and your baggage before you leave the house? Let me know. Okay, many of you are saying no. The one who said you, what is you? Okay. So it means, therefore, that these guys are behaving differently from the ones at the main gate, right? These security guards are behaving differently, and we will call them stateful. because they have memory. They remember, right? Once they've allowed you to enter, when you are leaving, they don't check your ID again. That would sound like crazy, right? So we call these people security groups. So whenever you hear security groups on AWS, okay, just think about the security guard at the home level, right? And later on, we'll get to realize that these homes I'm talking about are nothing but servers, right? And for every server, we can define a security group around it. As simple as that, right? So the whole picture will now look like inside the federal private network, I have some servers that needs to be in a very secure area, and I put them in a the very secured one, I'll put them in a private sub network. And the servers that actually serve the whole, let's say our website, that server needs to be able to serve everybody in this world, right? So I'll typically put that server in the public network or public farm because it's going to serve my web page, like where I'm serving the Cloud with Chat from. You just type cloudwithchat.com and you want to see my page, right? So that web server, I'll put it inside the public farm because it's serving the public. But my database server, which contains my data, okay, data of the people who have signed up for the course, people's private information, their emails, their phone numbers, I wouldn't put that server in the public subnet. I'll put it in a private subnet or private farm, right? So that it provides more security for data, right? Before the data guys come for my head. So we'll get to see all of that shortly. Okay, now another interesting concept we use on the cloud is that, let me bring to the farm level first. So on the farm level, now we know each other. Okay, let's say within a community, we have homes, and we've made this interesting agreement. No, like before you come to my house, my security guard would have to check his list, right, to see whether you are invited. Fine. Now there's another strange rule. If my security guard is escorting someone from my home to your home, you have this special agreement with me that anytime my security guard brings someone from my home to your home, your security guard should just allow the person to enter your house. And I may also define the same rule that if someone's security guard, okay, is leaving, let's say I'm a security guard is escorting someone to Kojo's farm, Kojo's security guard should also allow the visitor to enter his home. As simple as that. Now, this is what we call security group allowing another security group to bring in traffic. And we will see that interesting concept also. But at this level, I hope it makes sense to you. Does it make sense? So this is a security guard bringing someone to Kojo's area, and the person is allowed to come inside, right? But if you come without the security guard escorting you, you will not be allowed to enter. So that's the animation you see there. Let me replay it. So the security guard is the security guards are the ones wearing the hat, right? Let me play it again. So the security guard bringing you, you're allowed to enter, right? But if you are coming by yourself, you'll be bounced. Is it good? Do you understand that little concept over there? So sometimes you see us defining a room, and the rule is we are allowing a security group. So allowing a security group is just like allowing a security guard to be able to bring stuff. That's all. Awesome. And then that is all. So stateful, we've seen security guards that they are stateful. They remember you when you are coming in. They check your details on their list. You see the list is carrying here. And when you are leaving, they don't have to check your details again. They just leave. So they check you. This is the checkpoint. They are checking. Then once you are done, you're allowed to enter. But when you are going, see, you just go right away because security groups are stateful. Awesome. Okay, let me know. Has the explanation been very clear? The analogies, the story used, the scenarios, are they clear? And it's part of the stories that are on your page. So you can always go there and go and look at it again. And now we're going to put all of it together. If you are ready, tell me ready, and I start. I'll put everything together, and then we hit it. Okay, only one person is ready. Okay, 3 people. No, I want 10 people to be ready. Okay, I see. Ready, 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 ready. Okay, awesome, awesome. Okay, you guys are ready. I'm also ready for you. Great. Now we are putting all of this together, trying to understand how everything works. After this, we'll take a short break, then we'll look at our slides. Okay, so 2 parts, 2 purposes. Now, a public farm has a gate that opens directly to the road. You can see it here, right? Strangers can walk in and buy maize. They can come to the public area. Okay. The whole point is that we want the public to be reachable. You can see it here. Very easy. The private farm has no access roads. There's no road anywhere coming to this private farm, right? This, to get there, you must first enter via the public farm's path, walk through it, and take a small inner trail to the granary. So the only way to access the private farm is to come through the public. You can see that here, the path. Okay. And this is exactly how we set up networks. Okay, at least the basic form on AWS, right? So we can have a public subnet, private subnets, and then the only way we try to reach the private subnet is through the public subnet. Let me increase the size of this thing and then add some more explanation to it. Okay. Good. Okay, team. I think I went off. How many minutes have I been off? Sorry, I don't know how my microphone went off. Sorry. Let me just get started again. So we have this private subnet, right? This public contains our web server, cloudwithchat.com. Private is where my database is. Awesome. Then this whole farmland is my VPC. We've understood that. Now, this road over here, this road represents the external internet. So we have cars from every other place in the world moving on this road. This is the external internet, right? So this internet we can allow traffic from the internet. So let's say you are using the internet from your home and you type www.cloudwithchat.com. Then your traffic is going to be directed where? To my web server. But where is my web server? My web server is in the public subnet, right? So the one www.cloudwithchat.com won't have access to my web server. But wait over there. There's a gate here, right? This gate. This is the internet gateway. So the internet gateway is attached to the VPC. Look at it carefully. The VPC is the external boundary, this line, right? So the internet gateway is attached to the VPC because the VPC is the boundary of our whole farmland. Good. So external traffic on the internet must come to the internet gateway. Now, team, tell me, what do you think will happen if I create a VPC and I don't attach an internet gateway to the VPC? Tell me in the chat, what do you think will happen? Let's brainstorm. We have our farmland, there is no gate. What happens? What would that mean for our network, the network that we've architected? Okay, I'm reading the chat. Someone says you're open to danger. Are you sure? I don't have a gate and I'm open to danger. Okay, we'll come to that. Someone's saying that it will remain a private cloud. Okay, yeah, because nobody can come in, right? No flow. Okay, yeah, I get no flow of traffic. No one comes and no one goes out. Okay, good. People can't access my farmland, right? Good, good. So the network cannot be accessed to the public. Excellent. So that's the whole concept. The internet gateway is the gate we place on the VPC so that the VPC can have external internet traffic entering it. So if you don't have this internet gateway, okay, if there's no internet gateway attached to the VPC, people will type www.cloudwithchat.com. We have configured everything in the VPC perfectly. Everything is correct. But because you don't have an internet gateway, people typing www.cloudwithchat.com cannot access my website because there's no gate for the traffic to move on the internet into my web server. So that's all. So each time you create a private cloud, virtual cloud, which is your farmland, please make sure you attach a gate. If you want traffic from the internet or you want internet access on your farmland. So just like I go and build a farmland somewhere and I don't, let's say in a hinterland, and I don't have any internet access, right? I can just buy Starlink, right? And then my farmland will have internet access. And purchasing Starlink is like giving it an internet gateway so that the whole farmland can have access to internet. It's as simple as that. That's all the work of the internet gateway, to give access to the internet to the infrastructure we have inside here. Okay, is it good? So we've understood the internet gateway also. Very simple concept, right? Very simple. That is what gives access to internet to every other thing inside here. Now, let's continue. One more thing to explain. Now, everyone on the internet is able to access our public subnet. But what about the private subnet? It is a no-no. We are not going to give anyone on the internet access to our private subnet. So that is the rule. No one on the internet can access our private what? Subnet. It's that simple. So when we are creating the rules, we will allow people to access the resource on our public server, right? And we deny access to the private. And the reason why we've done it, or the way to just configure this easily, is to only allow people who are inside this public to be the only people who are able to come here. So that's why we have a small pathway. No one else is able to enter the private farmland except you are joining and you have the enough credentials from the public farmland. Good. Now, what about someone is living here in a private farmland and really needs to access the internet? This is where the whole problem or another question comes. Does it mean that once I'm on the private farmland, I cannot use the internet? So we are going to solve that problem within a second. And we are going to use another thing we call the NAT gateway, right? So that's how we grant access to the internet to people on the private farmland or in the private subnet. So let me pick my drawing tool and create a NAT gateway. So I'll create a NAT gateway inside the public subnet. Why inside the public subnet? We are going to answer that question right now. So NAT, so I'll create a NAT gateway and I'll put it inside the public subnet. Okay, good. Now, if anyone, now this is what the NAT gateway is doing. Let me just make it simple. Pick my tool. Okay, good. So this is what happens. From the public internet, if you want access, you're coming from the public internet, right? You want access the private, okay? You'll be denied. You can't go. The only way you can have access to the internet is that you have to go through the NAT gateway, right? And unfortunately, the NAT gateway is just a one-way thing for traffic origination, right? So it only give access to the internet to those who are in this private farmland. So when I'm the private farmland and I need internet access, I have to go through the NAT gateway, right? I have to go to the NAT gateway before I can get access to the internet. Let me make this one proper. My drawing skills are not the best, but I'm doing my best. This is what we do. Good. So someone inside here is able to access the internet because he may also need the internet, right? But he is doing that through the NAT gateway. And the NAT gateway itself is inside the public subnet or the public farm. We have to place it inside the public because it's only the things in the public that have access to internet because of the internet gateway, right? If we place the NAT gateway inside the private subnet, then we've not solved the problem. The NAT gateway itself will still not have access to the internet. So the NAT gateway we place inside the public subnet. This is a question that comes almost all the time on the AWS exam. Where is the NAT gateway placed? It's not inside the private, but inside the public, so that it will also have access to the internet provided by what? The internet gateway. But the reason why it's able to still offer protection is that it is a one-way sort of thing. If you try to originate traffic from the outside through the NAT gateway, the NAT gateway will block you. If you're a hacker, you can't go through the NAT gateway from the outside. But if I'm in the inside and I need internet, I request for internet, it goes to the NAT gateway, then the NAT gateway will also send it to the internet gateway, then I get a response or a feedback from the internet to myself, right? I am the only one who can ask for anything from the internet. No one can just start communicating to me from the internet if I'm in the private. But I can start communicating to you if I want to through the NAT gateway. And this is the perfect and amazing way to prevent hackers from accessing the data in my private subnet. They cannot start hacking me, but I can initiate a conversation, maybe to browse google.com, and I'll get a response back. I am using the NAT gateway. Awesome. And how the NAT gateway was able to also get me the information back? It is simply going to be based on the rules. Now we are getting very technical, right? The NAT gateway itself still has to use this narrow path over here that we define to get to me. We are done. This is the most difficult thing I've explained today. And we are done. I'll show you the animation very soon. Is it good? Or I should go over? I can still go over. So let me just summarize that. All the guys in the public farm, they don't have any issue with getting internet access. They can just get it through the internet gateway straight away, and they are happy. But those of us in the private farmland, in the private subnet, we have to get access through the NAT gateway. So the NAT gateway is like our middleman. And he's supposed to be there because he protects us from external hacks, right? He protects us from external hacks. So when we are accessing the internet, we have to go through the private tunnel we have here to the public. It goes to the NAT gateway. Before the NAT gateway now accesses the internet gateway, then we get internet access. Awesome. Let me go to the chat. Maybe there are some questions for me to answer. Oh, everyone is saying it's good. Is it clear? So we understand VPC, we understand public subnet, we understand private subnet, we understand how both of them access the internet. Public is just straight through the internet gateway. Private has to go through the NAT gateway first before the internet gateway. Are we good? If you are good, just type good in the chat and let's continue. Yeah, so we are able to only access the NAT from the private subnet. Yeah, so we create rules, okay? And in the rules, we say, if anyone in the private subnet wants to reach the external internet, usually the external internet will call that one, or will usually designate that one as 0.0.0.0, right? So this is how we reference the external internet. 0.0.0.0, right? So we'll say if anyone is in the private and want to go to the external internet 0.0.0, we have to direct you, right? So from the private, if you want to get access to the internet, then we will direct you to what? The NAT gateway. This is where you should go. This is where your traffic should go and hit NAT gateway first. Then automatically the NAT gateway also has access to the internet through what? The internet gateway. So that's this like the flow. This like the entire flow. Because the reason is very simple. The NAT gateway is in the public, and every other person in the public, if they need internet access, they have to go to the internet gateway. That's like the main gate to the main internet, right? And the internet itself is the road we are seeing here. Awesome. So intranet is just a local, someone's asking about intranet. Intranet is just a local connection of what? Computers. So when you are connecting your computers locally without any external internet connection, then you are basically talking about intranet. Internal, that's like an internal form of network. Okay. Then we are going to take our break right now. When we come back, we continue with part number 2. But before we do that, any questions? You can type a question in the chat and I'll look at it. These are real technical stuff, right? But try to break them down so that everybody gets clear understanding of what we are talking about. Okay, so a summary, the whole farm in AWS terms, right? So we've now finished our story, Nkrumah Valley story. And we now know what a VPC is, right? What subnets are, what knuckles are, what security groups are. So the whole farm is our VPC. The farm sections are our subnets. The session gates, so you have knuckles for every subnet, right? That's the security guard at the whole subnet level. And for our servers, the security around them, we call them what? Security groups. Awesome. Team, this story is always here for you. You can always come back to it. So you go to our story explainers, is there. That's Nkrumah Valley. Okay, let's take a quick 3 minutes break, and then after the break, we come back and keep pushing. So let me make it 5 minutes. So go and cool off and come back. 5 minutes time. Okay. See you in 5 minutes. All right. So let's get on to the slides now. So we've already done a lot of this, right? So I just skim through it. We've introduced VPC subnet routes. We'll talk about route tables also shortly. Then security group versus knuckles, I've explained that. RDS, I also talk about this. Then we look at the two-tier architecture. Then serverless with Lambda. Okay. So about 11 slides and we'll be done. So team, stay with me. Okay. So I always say, before you try to start building things, I know that there's always this urge to always start building. But we have to really understand what we are building, right? The conceptual understanding should really be solid before you start building or going to the console to do stuff. So it's possible to pass the AWS Cloud Magister exam without even ever touching the console or ever creating an AWS account. That's what I want you to know. It's not required for you to build, but we've intentionally added the building aspects, right? So that it will improve your understanding, right? But at the cloud practitioner level, okay, the exam you're going to write after this course, that's if you really want that certificate from Amazon or AWS. It doesn't require you to do a lot of these hands-on stuff, no. At the practitioner level, you just need to understand the concepts, like how I'm explaining them. And it's enough to get you the certificate, right? But it's just that with Cloud Richard, we don't believe just in certificates, but we want you to get your hands dirty. We have a real feel of everything. That's why we've added so many labs to the program. So please take advantage of the labs. And if you're able to set up your AWS account on time, fine. You can practice the labs. If you are experiencing delays, right, like some of you are experiencing, don't be discouraged. You can still watch all the videos and have the conceptual understanding. That's the most important thing for this exam. Not necessarily the hands-on labs, but the conceptual understanding. You can get it from the videos, the explainers, right? And then you can still sit for the exam and pass it perfectly. Because that's what we expect cloud practitioners to do, to have an understanding. Okay. So that's just a word of encouragement. In case your account is still not going through, don't let it worry you. Attend classes, attend lessons, understand the concept. You can write that exam anytime. You can set up your account later on and write the exam or practice. But for now, you need to understand these concepts. And that's what the exam actually tests. Good. If you are good, type good and let's get started. Give me a sweet and let's get started. Awesome. Awesome. You guys are very responsive and I love that. Okay, great. So let's move on. So VPC. Now, this is a part of the slides you guys can even explain to me right now. Right? See, if I ask some of you to unmute and explain, you can do it perfectly for me because we've gone through that explainer. So it's just like our own private network inside AWS. And then we keep our stuff inside there, our services, the services that we want to deploy, we deploy them into the VPC. But just take note, it's not all the AWS services that are restricted or deployed into a VPC or limited by the VPC concept. No. Some of the AWS services exist outside the VPC. Though you can create a private connection to them, give them an endpoint to your VPC, right? But they don't live inside the VPC. So your homework is to find out which AWS services live inside a VPC or are deployed into the VPC, and which of them live outside the VPC but can still be connected to the VPC. So that's your assignment. Just do that research work. And obviously, you know that servers like EC2 servers, from what we've explained so far, they are part of the things that are deployed into a VPC, right? NAT gateway, you can see that it is deployed into a VPC. But the rest, go and find out. Go and find out. And the database, too, we can have some of the services being deployed into the VPC. But what about the ones that are not deployed into the VPC? Go and find them out. Awesome. So our VPC gives us a private area around our stuff. It's a digital fence, right? And it's isolated from every other thing on AWS. So nobody has access, and we've explained all of this. So we can decide to give it access, okay, give things within it access to the internet, and we've also seen that. And when we are creating this VPC, we can decide how big the VPC is or how small it is. So that's what we do with what we call the IP range. So IP range, that's the number of addresses we try to make available for our resources. So if you imagine it as a real estate plot, on a real estate land, right? When people are building a real estate area, what do? They plan, right? So let's say they have the land they've bought. Then they know the number of houses they want to build on this land. So let's say they want to build, let's say 1, 2, some of the houses are bigger than others, right? 4, 5, let's say 6. Then maybe they have another big area, maybe playground or something, and a hospital, blah, blah, blah. So if they know that we need about 1, 2, 3, 4, 5, 6, 7, 8 buildings, then they are going to maybe request for 8 addresses, right, for each of these buildings. And that's what we do with the IP address range. We should know the number of items that can potentially be deployed into our VPC. And we must make sure we make provision for that. So this is a provision that we are making. We'll get into the details of what this means later on, right? We call it CIDR, Cluster Domain Routing. So we'll get into it. These are IP addressing and CIDR and what have you. We'll get into it later. But for now, let's know that when you see something like this, it's just a way of providing addresses for the resources in our VPC, right? And we plan this beforehand. You don't do this after you have done everything. No, you plan this, and then as you are creating the VPC, it will be part of the things that you configure the VPC with. Awesome. Now, when you create your AWS account, AWS always creates a default VPC for you, right? So in every region, there is one VPC created for you that you can start using immediately. And that is the reason why when I started explaining EC2, you see, during the process of launching an EC2, there's a VPC. I don't know whether you took note of it. You took note of it. There's a VPC that we deploy the VPC, the EC2 into, the server into. And that is the default VPC. We didn't have to create a VPC before we deploy the EC2. We just deployed or launched the EC2 into the default VPC. So just take note of that. So that's why you didn't see me creating any VPC, because I was just making use of what? The AWS default VPC. Awesome. Let's continue. We go to the next one. And I've explained how traffic flows inside the VPC, right? So from the external internet, we are now aware that this traffic must move through the internet gateway, okay, before it gets to what? The subnets, right? So the first one is the public subnet. But if anything in the private subnet, like what we talk about today, the RDS database, right? If it needs internet for updates or anything, then we must provide a NAT gateway here so that it can get internet through the NAT gateway to the internet gateway, right? This is what we've done today. Awesome. So this is how internet or traffic will flow inside the VPC. So the public subnet has a route to the internet gateway, right? And the private doesn't have a route to the internet gateway. If you want to private internet access, then we have to use the NAT gateway. Awesome. I hope it's clear. If it's clear, type clear in the chat and let's just continue. Okay, people are saying clear, clear, clear. Let's continue. The next one. Security groups versus knuckles, right? We've already gone through these two guys. The knuckle is the guy at the airport, remember, or the guy at the main gate, the subnet level. Then the security groups are the ones at our home, the security guards at our home. These ones are stateless, these ones are stateful. So let's just go through this quickly. The first one operates at the instance level. Instance just means server. And I said that those homes that we were drawing, those hats, they were representing what? Server. So we create a security around our server, right? And this security we call the security group. And there's just rules, allow and deny rules, right? When we talk of rules, we just allow maybe HTTP traffic coming from port 80. So there are some special doors that we open to our servers on the internet. So HTTP, if you want HTTP traffic, you must open the door called port 80, right? If I choose not to allow port 80, it means I won't get internet access because most of internet traffic is on HTTP. If not HTTP, then you see HTTPS. HTTPS. And HTTPS is also on port 443. Port 443. Right? So these are just doors. So these doors, we open them with the security group, right? So the knuckles and the security group, this is what they do. They just open these ports. They will allow, so when I say allow HTTP, that's port 80 will be open. Allow HTTPS, port 443 open. If I don't create these allow entries of my security group, that's the list that we give to the security guard, right? You can't enter. It's as simple as that. If I want to do SSH, SSH is port what? You can use port 22, right? For SSH. Okay, any questions? Let me go to the chat. So that's what these security guards do. We give them rules, who to allow and who to deny, and then they just go by those rules. Okay, awesome. When we are creating it, when we are creating this in our labs, we actually get to see I think we've already used security group rules already in our previous labs. But Knuckles, we've not yet seen that, so I'll let you see that very soon. Okay, Claire. I'm getting Claire in the chat. Awesome. Let's continue. So you said security groups are stateful. Please don't forget this. Highly examinable. Security groups are stateful. They keep memory, right? Once you are allowed in when you are going out, they don't have to check you. The Knuckles are what? Stateless, right? You must allow in, and when you are going out, we must check you. That's all that this one is saying here. You must state what is allowed in, and you must also state what is allowed out separately, right? But for security groups, we will only be concerned about what we call the inbound rules, what's allowed in. Once you get in, going out, we don't care. You can go out anytime you want. Okay. So over here, we only have allow rules only, no deny. And the reason is simple. Deny is like the default. So automatically everybody is denied entering our house, right? Except you're on the security guards list. So automatically it's denied. So we don't even have to tell the security guard, deny Kofi, deny Ama, deny. The list will never end. So you just tell him, see, forget about everybody is denied. Only allow these three people to visit me today. So that's why we only state what? Allow rules only. But over here, we have both allow rules and then deny rules. Okay. As I said, the default is what? Deny all. Then this one, the default is what? Allow all traffic. And as I said, we can reference other security groups, right? This is the powerful thing I said. If your security guard is bringing someone to my home, I can have a rule that says that this security guard, whatever traffic is bringing to me, allow. Sometimes when you are creating the security group rules, especially from the when I create the two subnets, private and public, the easiest way to connect these two is that if there's a server, if my web server is inside the security group here, and my database server is also inside another security group here, let me use this to show. So the server is what is inside the red box. The red inside is the server. How do I allow these two servers to communicate? Now, this box over here, the box, this one is a security group. So let me say security group 1. Right? And this one will be security group 2. Security group 2. So security group 1 is protecting what? What is it protecting? Security group 1 is protecting this server here. Security group 2 is also protecting this server here. So I can make these two servers communicate by saying that I'm allowing this security. The security group is this box. This box is the security group. And it's also the security group over here. The only way I can make my web server get data is that I'll allow these security groups to have access to each other. So when I'm creating the inbound rule, I'll say that I will just state inside security group 2's inbound rule that if something is coming from security group 1, okay, allow it to come. Anybody inside security group 1, which obviously is our web server, right? Allow traffic to come from it. So even if a hacker gets access to this subnet, because it's a public subnet, right? If a hacker gets inside here, the hackers are the bad guys. If they get inside here, they still can't access our database. They can't access our database. Why can't they access our database? Because they will also have to get inside this place before they can access the database. So this is also another layer of security. So once you get inside the public subnet, you still have to get inside the security group, which is another worry for them, before you can now communicate with this server. So once you have access to a public subnet, doesn't mean you automatically can get my database. You must now come inside here before you can use this server Now access my database. So this is another level of security. Okay. Don't worry about the technical details. We'll go over them again. But if you have any questions, please put them in the chat for me. Okay, let me go to the chat. And all I'm seeing is clear. You guys are smart. Because I myself had to struggle before understanding this stuff. But the way you guys are getting it so easily, I like it. Okay, awesome. So the recording is there. If you want to go over it, you can just replay this recording when you get it, okay? Let's move on. Next thing. So please, these things are for your memory, right? Memorize them because you see a lot of questions on them. And you should also be able to explain them as a cloud practitioner. Lovely, sweet. Let's go. Okay, now we've spoken about all of these things. Now, the database server we are going to use in the lab, okay? We are not going to create a whole server and we'll have the problem of worrying about how to patch and update that server every time we need to update the server. It's a lot of problem. So AWS usually recommends that instead of creating your own database server and uploading your own database software on it, see, they can just give you any database server you want to use. If you want to use MySQL, they can give you PostgreSQL, they'll give it to you, right? These are traditional database that people use in their companies, right? So let's say you're already using MySQL in your company and want to move your database to the cloud. You can migrate all the data you have in that database into RDS. Then when you are creating your RDS, all you have to do is that just tell AWS that you want a MySQL database because you're already using MySQL on your premise. And they'll give you the MySQL, and then you now migrate all your data from your local MySQL to the AWS MySQL. If you're also using PostgreSQL in your office or your premises and want to move to the cloud, RDS still gives you the option of choosing that. Then your migration will be smooth. MariaDB is also available. If you're using Oracle database, you can also choose that. SQL Server for Microsoft, you can also do that, right? And even have another one we call Aurora, which they claim gives you almost like 5 times the speed of whatever you are using, whether MySQL or PostgreSQL. Okay, good. So RDS is just a managed service. You don't have to create it from scratch. With just a few clicks, you can have this server running. And that's what we want to use for our labs. We don't want to go and stress anyone creating a database yourself, updating and patching and all of the stress. No. So when you're doing this, usually your database engineers will not be happy or they'll have less work to do, right? They have to worry too much about updates and patches and all those things, which actually waste a lot of time. So that's RDS for you. Okay. Okay. Let's do the next one quickly. Now, before that, you will be hearing this term over and over again, high availability, right? What does it mean? It means that AWS makes sure that we don't just provide the database in just one location. What about if something happens in that location and it goes off? There's a disaster or something of that sort, right? Power outage or anything. So they make sure that they create about 3 or 2 versions of it. That if one is taken down, the other one is like standby, can just replace that one and then your customers don't have any delay or bad experience using your software or your website or whatever it is. Awesome. So the architecture we are building for our lab, let me just highlight it quickly. So you'll create a VPC, right? In a very easy way, few button clicks. Then we'll create a public subnet and a private subnet. We'll put our web server, obviously, where? In the public subnet. I've already explained this, right? Then when we deploy the database, we'll deploy it to the private subnet. We'll enable multi-easy deployment. And then because our web server will be serving the internet traffic, right? We're serving everybody all over the world. What will we do? When we are creating a security group rule, look at the rule that we will create. We'll allow what? Port 80 and 443. I've explained them already. This is just basically saying that anybody who types our website, cloudwithchat.com, should be able to access it, whether using port 80 or 443. 80 is HTTP. But Cloud with Chat itself, currently our server is serving on HTTPS. So indirectly means that we are using 443, right? So once you just type the domain name in your browser, you have access Cloud with Chat. Okay, awesome. Then over here, how do we make sure that this server here has access to this database? Look at the rule here. We'll allow 3306. Now 3306 is just a database port, right? It's just a port for this database itself to work in the MySQL database. So MySQL database needs port 3306 to be opened. Okay, fine. That's why we make the database work. But what rule will allow this EC2 to communicate with our database? Because our web server needs to be fetching data. If I come to our web server and I enter my name, I enter my details, and I create an account, and I log out, and I log in again the next day, I want to be able to see my details, right? So this web server will have to go and fetch my details and come and display it to me. So this web server really needs to communicate with my database server. So look at the rule here. I'll add an allow group. And what does allow group do? It just allows the security group of this EC2. Anything inside this EC2 security group. Now, how the security group look like? As I said, it's just like you can just use a rectangle. So you can say that this is the security group. Right? We'll just allow anything inside this security group to be able to what? Communicate with our database server, which is also in this security group over here. So that's why we have two rules here. Very, very simple. Okay, we move on. So everything is coming together, right? Right from the beginning. So if the concept is there, if the conceptual understanding is there, you realize that when you come back to the technical drawing board, explaining stuff is very easy. So this is what we call a two-tier architecture. Two-tier architecture. Two because we are using two levels. Public is just one level, public subnet is one level, and the private is also what? Another level, right? So this is two-tier. We can have a three-tier architecture. That's a little more advanced than this, but we'll look at that. Probably one of our office hours. One of our members, I may be myself, I may ask one of our mentors to just take you guys through a three-tier architecture. Okay, but for your homework, your lab work, you have to deploy this architecture. So this is what you're going to do as your lab work. Awesome. Now, AWS Lambda. This is the last thing I'm explaining, and then we are done for today's session, right? The rest of the things, like CIDR blog, 5 mistakes beginners make. This is your personal notes, so you have to read this yourself. Then the 11 is just a summary, right? So the only thing I have left to explain is Lambda. Please, guys, I'm giving you 2 minutes break. 2 minutes break, walk around, take some water. We are going to do something serious now. I'm going to explain Lambda to you and why Lambda is important, right? So 2 minutes, I'll be back. So make sure you stretch a little, Just move around and then come back to your seat. 2 minutes, and we start Lambda. And I'll use it to explain what we mean by serverless. And I'll compare it to what we've discussed so far. Then we will naturally appreciate what serverless means. If you are good so far, type good in less than 5 minutes after the break. We'll be done with today's class. Then I'll just walk you through the lab a little, then we close the session. Then tomorrow, we have a guest speaker. One of my colleagues from my former company will be joining us, Moise Khan, to just give us, he's actually more into DevOps than I am, right? I am more into the AI cloud, but he's into the DevOps AI cloud. So I invite him. He's also not, I wouldn't say he's like 20 years experience, but he has quite an experience, let's say 5 years experience in the development space. And I feel like I didn't want to invite someone with 20 years because you may not be able to relate with someone like that easily. But someone who's like also an early in his career, 5 years, 3 years, the person can communicate a lot of things to you that you really understand and appreciate more than somebody who is like 50 years in the career. So tomorrow we have Moise Khan joining me 2 p.m. GMT. That's just an announcement I want to make before we go for our break. Awesome, guys. See you after 2 minutes. Take care. Okay, awesome team. We are back. Let's get on to Lambda. Insert a new slide here, and I'll use it to explain Lambda. Good. So let's take this short scenario and let's break it down. So we have a scenario. A scenario, right? Mr. Kofi again. Okay. He wants to move to the AWS cloud, right? So you are the cloud architect. The farm owner has a website he sells his farm products on, and he just wants to move to the AWS cloud. So you're on a call with him. Guys, I should have simulated this call with one of my mentors so that you appreciate how cloud architects really work. Okay, but don't worry, we'll do that later. So I'm just going to role play two people at the same time. I'm not a good communicator, but I hope I do it. So Mr. Kofi calls in. Shaq, I want to migrate my current infrastructure to the cloud. And I've heard that the cloud can really help me save a lot of costs and also make my services available to everyone all over the globe, right? With very little latency or delay. So I was watching one of the videos and you were speaking about high availability, scalability, and all of that. And I just got interested. So can you kindly help me to migrate what I currently have to the cloud? I really appreciate that. Okay. Thank you, Mr. Kofi, for calling me. I'm happy to serve you, right? Now, can you just walk me through what you have currently so that I will know how best to approach all of this and what to recommend, and then we can discuss what works best for you. Oh, okay. I thought it could be that straightforward. I didn't know I have to give you some details about what we have. See, I'm not a technical person. Let me put our cloud, no, let me put let me say, infrastructure engineer on the call. Okay, give me a minute. 1 minute past, infrastructure guy comes to the call. Hello, Mr. Shad, I'm happy to walk you through what we currently have. So let me take you to what we currently have. Now we have a 3-tier architecture, okay? And Mr. Shad, this is what we are using. So we have a web server, right? Then we have an API. Then we have a database. So we are using this simple architecture, web server, API, database. And in actual sense, let me say we are using a 2-tier architecture. I think I got that wrong, Mr. Shak. So our API actually lives inside our web server. Guys, take note, if you don't understand any of this, don't worry. I'll explain all that the engineer is saying to you. So let me take off one of these things away. So this is what the guy has just explained. They have 2 things. A server is just a computer. Always remember that. So, okay, now Shad is about to speak. So can you walk me through what happens when somebody is accessing your website? Okay. So Shad, this is what happens. Our web server takes the request. Okay. This is our web server. And we are using a computer for that, a desktop computer. Then we also have a database server. So our website is on our web server, and our API is also designed by ourselves. We design the API. So when someone is at home and the person is accessing our website with his or her laptop, the request comes to us, and then the web server, which is on all the time, 24 hours a day, 7 days a week, 365 days a year. The database server is also on all the time, 24 hours a day, 7 days a week, 365 days a year. So when you want to see you log in, you're supposed to show your picture, then your details on our website, right? The things you want to buy and your cart and what have you. The web server does all of that, but usually the data will be paid from the database server. So this is our simple infrastructure that we are using currently. And it really costs us a lot of money to keep these servers running all the time. And sometimes we have outages, power outages, it affects these servers. So we will be glad to have a system in the cloud which will not be affected by ECG power outages, because sometimes our UPS or generator is also not working well. So when the ECG electricity company takes away power and our generators fail, all these servers go off, and our customers or clients who are visiting our website, they want to shop and buy our farm products, they get 404. We cannot be reached. So we want to avert this situation. We want to be highly available. And also we plan to expand our market to other areas in Africa. So this is what we currently have. Can you help us? Awesome. I think I understand what you guys are using currently. And I'll offer a very simple solution which can save you a lot of cost and also ensure that you are highly available all the time. So let's start with something simple. So I'm going to use something we call serverless, right? Serverless. Now, the concept of serverless doesn't mean that we are not going to use servers. We are going to use a special kinds of what servers. So what we're going to do is that we're going to use one serverless architecture or serverless service we call Lambda, AWS Lambda, right? So I'll use Lambda to replace what you guys have as a web server, which is always on 24/7. I want to get rid of this problem, right? And Lambda will do that for us. Now, Lambda is like a small virtual machine or let me say micro VM virtual machine, right? So all I have to do or take from you guys is to know the code that you are currently running on Lambda, sorry, on your web server. So the codes on your web server, okay, the codes, I just need to understand your logic, right? So the codes you have, I need to understand the codes you are using. Then together with your engineers, we'll try to migrate all of that code or that logic to Lambda. So Lambda is just concerned about the code that is running the logic. Code, so the codes on the web server will come here, right, to Lambda. And you don't have to worry about operating system, you don't have to worry about anything. Lambda just thinks about only code. Now, the code will run on Lambda. Lambda's compute servers, okay, will handle everything. AWS will take care of the kind of computers, operating system, software that needs to run this code. You just tell us the language that you've written the code in. So currently, engineer, what language is your code using? An engineer says, oh, we are using Python. And I tell him, oh, if you are using Python, then when I'm creating a Lambda function, I will just select Python runtime, right? Python runtime when I'm choosing Lambda. As long as I just choose this, Lambda is ready for your Python code, all of your Python code. All the other things, you don't have to worry about it. Now, you also mentioned that you are using an API, right? So I'll not use Lambda to handle the API. AWS has an API service, okay? API is just like a middleman who takes orders and directs Lambda what to do, what work to do. So I'll just replace your API logic in your web server with an API gateway, right? API gateway. So API gateway. Awesome. And I can create this within 5 minutes. To 5 minutes, I can create your API service for you. Then if I understand your code, we can also migrate all your code onto Lambda, right? Then the database you're using, also 24 hours, 24/7, always on. I'll replace the database with DynamoDB, right? DynamoDB. Okay, so we've now have a first baseline solution for your problem. So we have moved it from a 24/7 always on to these services which are not 24 hours on. As soon as a request comes, they only wake up when there's a request. If there's no request, they all go to sleep. So you only pay for the time that a request from your clients have come in, right? You only pay for that period. But so the request that comes from your web apps or those who are using the web apps or your website, when they come, they go to API gateway. API gateway will wake up Lambda. Lambda, there's work to do. If Lambda needs anything, it goes to the database, go and fetch it. When they finish everything, they give it back to the API to the customer on their website. Then they all go to sleep. So this will go to save you lots and lots of what? Money. Awesome. We are done. We have now helped them to understand how they can migrate from on-premise into the cloud and take advantage of Lambda and other serverless services like API gateway, database like DynamoDB, to do the same thing they were doing on their premise now in the cloud. Hooray! Mr. Kofi and the engineers are happy. They are now moving to AWS Cloud. Awesome. Guys, I hope you understood all that just went on. This is what we call one-man show. This is just a naive story I'm giving to you. Sometimes it can be more detailed than this, it can be more technical than this, but at least you know what is going on. So serverless just means that the thing only comes up when there's a request for it to do work. When it's done working, it goes off, right? That's basically the whole idea. So there's actually a server, but that server wakes up to do work. When it's done, it goes to sleep. And that's how come we save lots of money and lots of cost. Then Lambda can also, when there are so many requests coming in, Lambda can automatically multiply itself to about 1,000. You can have 1,000 of them concurrently. Concurrently means at the same time. So if about many requests are coming, Lambda, the whatever code you have here, Lambda will just replicate itself about up to 1,000 to just help serve the traffic coming to your website. And that, my friends, is high scalability. It can scale to meet the demand of the traffic coming. But your web server, if more people are visiting your website, are you going to call the people you bought the computers from to bring you more computers so you can serve your clients? That would be crazy, right? So you've already realized your computers your server is burning. It cannot handle the traffic that is coming. But Lambda doesn't have that problem. It can replicate itself. We can have up to 1,000 concurrent requests serving the traffic that is coming from your website. That's scalability for you. And AWS also makes sure that Lambda is always available, right? There are no downtimes. When ECG goes off, your servers are not on your premise, they are in the cloud. And AWS takes care of power, cooling, everything for these services. So you don't have to worry about ECG bringing your servers down. They are always on. And so the client is happy and is ready to move forward. Okay, we are almost done. We are almost done. So let's go back, look at the facts about Lambda. There are more detailed notes that we made available on the site, on the page, so make sure you look at them. And they also have some extra recordings and videos we've also added on our YouTube channel. So make sure you just look at them, okay? Okay, so Lambda has some upsides and also some downsides, right? So you have to also look at that. Now, if the processing Lambda has to do, let me just mention that one, it's going to take more than 15 minutes. Lambda will disappoint you. Lambda cannot be running code continuously for more than 15 minutes. But for things like processing orders, storing things in the database, retrieving something from the database to show for the web server, those things are less than, they are just like seconds, or they are all under 1 minute. Lambda can do all of that. But if you have a very long running workload, that's going to keep processing and processing for more than 15 minutes, then Lambda will not be the best option. We can use, then we may have to go back to EC2 or something of that sort, right? Okay. So one thing I should mention is that I could have replaced their web server with an EC2. But would I have solved the problem of 24/7 always on? If I had used an EC2, it can also hold the same API and web server for us. But EC2 is also an always on service. It's not like Lambda. So if you really want to go serverless, as we are saying, that's why I did not choose EC2. That's why I chose to use Lambda instead to save cost. Because with EC2, you are paying for every single hour, as I explained last week. Awesome. So Lambda, 15 minutes. And also it has a small, the memory is not so big, right? From 128 megabytes to 10 gigabytes. Anything more than that, Lambda cannot handle for you, right? But there are other services that can take off longer running workloads. We have ECS, we have Fargate. You can also have something we call step functions. We'll look at them later on. But Lambda is something that can solve most of the problems most of the time. Awesome. So just bring your code. That's all Lambda cares about, your code. Don't worry about the server. AWS will take care of that. Don't worry about patching or idle costs. It's always been on. If there's no work, you are still being billed like EC2. Lambda doesn't have that problem. Now, we say Lambda is event-driven. It only wakes up when there's work, right? And work can come from an S3 bucket. Sometimes you can even upload a picture to S3 bucket. You want to change the size of the picture. You can use S3 bucket to wake up Lambda to change the size of the picture for you. It's also one of the labs you guys will be doing for me. Also, whenever there's an API call, like what I just showed you guys, Lambda can wake up and respond to the call. You can also schedule Lambda to work at specific times. Then we may have also what we call a queuing service. We can queue these kind of requests, and Lambda will go inside the queue to go and pick work up and do it. When they finish it, to go back to the queue and go and pick the next task. It's very interesting. We'll talk about that later. So the good side, you don't have to manage any server. AWS will take care of the server, the patching, all those stuff. Just write your code. That's why I was asking the engineer about code and not too much about the operating system they are using and all those kind of stuff. I don't need that. So you only pay for milliseconds, right? Only when the Lambda is running. And actually, for your first 1 month, for your first 1 million requests, it's even free. Lambda can process 1 million requests for your first 1 million requests. It is absolutely what? Free. This is awesome, right? Amazing. So this week's lab is going to be very interesting. We are going to upload images to S3 buckets. The S3 bucket will accept that upload. It will trigger Lambda, and Lambda will change the size of the image. Lovely, right? Sweet. You guys are going to do a lot of work for me this week. So today, I'll not touch the labs. I'll just walk through the lab, but I won't do the lab for you. If I see you guys are sweating too much, then I'll step in to help, but not today. Today is just to explain all the concepts. Let's go look at the lab. So we have lab 3. So lab 3 is where you just get your hands dirty with the VPC RDS. The lab 2 is where you do the Lambda image resizer app for me, right? And this, my friends, after you do these 2 labs, I will say that you are becoming a real cloud engineer. So today, I'll allow you guys to sweat today and even tomorrow. Maybe somewhere on Tuesday, if I see you guys are sweating too much, we'll jump into my office hours with myself or any of my engineers, and then they will walk you through the solution of these 2 labs. But let's look at them quickly. They are very easy, trust me. Very, very easy. Okay, so as I said, before you start work, you need to understand what you are creating, right? And that's what I've given to you guys today. We all understand what we are creating. So we are creating a VPC with public subnets, private subnets, and then we want them to communicate. And you only see 2 of the private subnets because of what I called high availability, right? Whereby we want to have the database having a copy of itself again. So that if something goes wrong, we can fall back on the second one. We call this one high easy deployment, highly available deployment, right? So we just choose a multi-AZ whenever we are creating a database with RDS, and to just create a replica of the database. Awesome. It's just a small button you just have to enable. That's all. You don't have to go and carry this on top of your head. No. Okay, so you create your own VPC, right? But you do it in a very easy way. We have 2 ways of creating VPCs on AWS, the hard way and the easy way. But this lab, we are using the easy way. So you search for VPC as a service, then you go to create VPC, right? Then you must select VPC and more. This is the easy way. Though if you go and choose the other option, you are going to create every single thing in the VPC yourself. Well, you may want to challenge yourself with that. Why not? I won't stop you. But you have to know that you sweat more, right? But if you choose the VPC and more, it'll be so easy. You just click, and choose all that you need. So create VPC. You give your VPC a name, right? Then you choose the number of availability zones. All of these things, you just pick the settings from here, the parameters from here. Then you NAT gateway can be quite expensive, right? So I will try as much as possible not to be asking you guys to create things with NAT gateway, right? So for the meantime, we will skip it for now. So you just click on, after you've done all of these settings, click on create VPC, right? Your VPC will be created for you. Then you have to verify your subnet and routing. So you just, these are all just clicking steps. I've put every detail here for you. So you click your subnet, then you go and look for your Cloud Reshad VPC. Then you should see 3 subnets, 1 public, 2 private, right? 2 private because of, as I said, you have a multi-AZ deployment for the database. Good. Then you go in there to look at the route table, right? And within the route table, you will see this. This one means the internet, right? So things going to the internet, you must direct them to what? The internet gateway you created when you were creating your VPC, right? Then you must also go and look at your private subnet, look at the route table over there. So now in the ACE route table, you realize that there's no route for what? The internet. You shouldn't create any route for the internet. Else you have defeated the purpose of it being private. Okay. Then you create the security groups, right? Then after you're done, you launch your instance, that's your EC2 web server. And you just follow all the guide here, right? You give it a name, instance type. You choose the VPC we created, right? Then you choose the subnet, the public one, because the web server should go to the public subnet. Then enable auto assign IP address. This will give it internet access. If you don't, you can't access this server. Then your RDS2, you go and create your RDS database, right? This is the fun part. So you just type RDS in the search bar, go to databases, and click on create database. You use these settings over here, right? Just fill it up with these settings. So standard create, choose MySQL as your engine. The version, anything that is 8.0. Any number, choose it. Then you are working with the free tier, right? And all these other details, just go with them, okay? When you get the VPC site, make sure you choose our VPC, what we created. Then public access, no, right? We don't want anyone in the public to be accessing our database. Then the security group, we created one for database, so go and choose that one. Subnet group 2. AWS will automatically create these 2 subnets for you, right? As we did in the VPC creation. Yeah, this will take about 5 to 10 minutes to be deployed for you. Then you have to connect your EC2 to your RDS and test it. So you can SSH into your EC2. By now, we all know how to SSH, right? Then once you're inside the EC2 instance, try and connect the RDS, right? Then when you are done, if you're able to connect from your EC2 to your RDS, then it means that your web server can communicate with your database server, and then you have successfully completed the lab. So there's a query you can, so once you connect to your database, okay, how do you connect? You use this string or this command. The only part of the command you have to change is this part. So whatever is here, these arrowheads inclusive. You have to delete this one. And then after creating your RDS, you get a URL or endpoint. You rather paste that one here. So that's the only change you make here. And then use it to connect to your RDS server. So once you are inside the server through your EC2, you just run this command, right? You create a database, then you use that database, then you create a table, you insert a value into the table, then you select the table. This will just show you this. Once you see this, it means you are done with the lab. Then when you are done, don't forget these cleanup steps, right? Because all the things that you have created cost money. I know most of you are on the free tier. AWS are giving you $300, right? But as a good practice, don't waste that $300. Learn how to save money. So when you are done, destroy all the services that you have created, delete all of them, and then but I only need this one. When you send a screenshot of this, it means you are done with the lab. You're done with the lab. Awesome. So this is the first lab. Try your hands on it. do your best, sweat, ask questions, we'll help you out. But on Tuesday evening, I will jump on a call with you and I will walk through the whole solution with you. But the best way to learn is for you to try to do it yourself. If you feel, then join the office hours Tuesday, 8 p.m. GMT. Then we walk through it together. Awesome. Any questions before I jump off? How have you enjoyed the lesson today? Hope you've enjoyed it. Let me see in the chat. Has it been an interesting lesson for you? Sweet. Awesome, awesome, awesome. So I will encourage you guys to share your learning on LinkedIn, okay? Share your learning on LinkedIn and send me a tag, right? So tomorrow, one of our mentors called David will walk you through how to create a LinkedIn post, right? Because if you are learning, who knows, recruiters are on LinkedIn and they are watching some of your activities, right? Some of your activities are shared. The algorithm of LinkedIn is that even people who are not in your connection, they can get to see the messages you post. Because LinkedIn is hungry for information, it's hungry for posts. People don't really post much on LinkedIn. So the few people who are posting on LinkedIn, their messages get to a larger audience. If you're on YouTube and you are posting, see, your posts don't go anywhere because people are posting all the time. The YouTube algorithm is not hungry for data or for posts from people or for content. But the LinkedIn algorithm, I'm telling you this as an AI engineer, I know what I'm talking about. So the LinkedIn algorithm is hungry for content, right? So once you start posting content, since it's hungry for content, it broadcasts your content to people who are not even in your content or contact list. That is why we must teach you how to take advantage of what LinkedIn to get a job or to get more connections which may potentially help open a door for you one day, right? So you can connect with me on LinkedIn. This is my account. You can look for me and connect with me. But most importantly, I want you to tag Cloud with Shad, right? Follow this page and tag it. At least this is what you can do to help promote what we are doing here, right? Follow the Cloud with Shad page. Right now, we have very few followers. Just 2 followers. It's very bad, right? Bad for the brand. So you guys should really help me with this. Follow, and each time you create a post, David will show you that tomorrow. How to tag. Somebody already did that, right? This student, and we're giving the person something, 50% discount if they want to write the exam, right? So follow our posts and then help us grow the community. Follow us on LinkedIn, Cloud with Shad, and hopefully we'll get more out of all of that we're doing. Thank you so much. Okay, there's one hand up. Let me take that question and then before we jump off. So the person is called user. Let me let you unmute. Okay, you can unmute now.
Oh, so all right. So Shad, good afternoon.
Yeah, afternoon.
All right, okay. So thank you very much for today's section. My question is with the labs, with EC2 instance. Are we going to use the one that we created in lab 2, or we are going to create anyone?
Anyone
Anyone.
altogether. Yeah.
So that means the one that we created in lab 2, we should delete that one.
Yes, you should have deleted it by now.
Uh,
So
okay.
don't keep your instances running, right? When you're done with the particular lab, please make sure to delete all the resources.
All right,
Delete
okay.
all resources. And if you don't have a LinkedIn account, please guys create it as soon as possible. You need a LinkedIn account to reach the global world market connections. Awesome. Any other questions? Okay, I believe we are all tired now. Let's get some rest. Click like, subscribe to our YouTube channel, like our pages, and then we have some promotion or something special we are going to unleash, right? And The reason why you also have to help us promote our page is that we are looking for funding. Funding not for ourselves, but funding for those who want to write the exam. So we started talking with some people, some interest groups, right? So that once you are done with the training, we want to be able to pay for your exams for you. Isn't that a good thing? Wherever you are, we want to be able to get vouchers for you so that you don't have to pay a cent, right? But those people are people who like to help big communities. So let's say they come to our page and they only see 12 followers. They be like, these guys are not doing work. But on our WhatsApp page, we have over 500 people on the page. So why can't all of we help boost this? Now, if we get to about 1,000, 2,000, then we can talk with those interest groups. Then they get us about 500 vouchers, 1,000 vouchers. And we just bring you guys the vouchers, you can use it to write the exams. So we really need the community support from you guys to be able to support you more. Awesome. Except you are not interested in writing the exams or not interested in any of these voucher stuff. But the exam costs roughly around $100. That's the first one, right? And we also want to be able to even teach you more up to the associate level. Associate level exam costs around $150. So you'll be able to get support from you guys. You promote what we are doing. You subscribe and like all our pages. We build a very powerful community. Then we can leverage on that and get you free vouchers from AWS and from other interest groups or stakeholders. Okay, if you agree with me and you want to help support the community, let me get a sweet before I leave the call. Thank you so much for joining today's session. Always glad to have you. Have a wonderful, wonderful, fruitful day. Take care.